In this video, we're going to take a look at parallel circuits. So by the end of this video, you're going to be able to define the term parallel circuit. And you're also going to be able to figure out both the voltage and current within a parallel circuit using the appropriate equations. So what is a parallel circuit? Well, it's different from a series circuit because it is a circuit where electrons have multiple pathways that they can travel through. If we take a look at our circuit here, if we're looking at the currents flowing through, we hit this point here where it can go one of two different pathways. It can go up here or down through here. And so that's what we consider to be a parallel circuit, is having multiple pathways through the circuit itself. So we can use parallel circuits to figure out what the voltage and the current is for different components within those circuits. For voltage, each pathway is going to use all of the voltage from the battery. And so what this means mathematically is that whatever voltage we have at the battery, if we have a parallel circuit, the same voltage is going to go through each of those loads. So if we take, for example, this circuit here, which has 6 volts, then each of the pathways it comes along here, so going through here, there's one pathway through one load, 6 volts would come through here. The second pathway, another 6 volts, and the third pathway, another 6 volts. Okay, so each of these pathways all get 6 volts as well. Now, looking at an example then, we can use that mathematical relationship of voltage within parallel circuits in order to figure out missing components for voltage. So, for example, if we had 4 volts at the battery, then coming through, we can see that this is a parallel circuit because it has 2 different pathways coming through. And we know that the voltage is going to be the same for both. So they will both also be 4 volts. For current, it's the opposite. So for current, the sum of the current through each of the individual loads is going to add up to the total current in the circuit. Or in other words, the current at the battery is going to add up to all of the currents within the components of a parallel circuit. So for example, in this circuit here, we have 12 amps. And then at each of the loads, one of them we have 5, one has 2, and the other has 5. All 3 of those add up to the total, which is 12. So what does that look like in a problem? Well, taking a look at this one here, we have 14 amps at the battery. We have 10 amps in one of the loads. And so this one here is going to be our total, our 14 minus our 10, or it's going to be 4 amps. All right, so now that we have 2 relationships that correlate to both voltage and current within a parallel circuit, what I want you to do is pause the video here, try solving this particular circuit, and then play the video again when you're ready to check your answer. All right, welcome back. So let's take a look at this circuit here. So first off, let's start with the voltage. We have 10 volts at this load here. We don't know what our initial voltage is though, or the voltage that we have in this one. We are recognizing though that this is a parallel circuit. So that means the voltage is equal everywhere within this particular circuit. So we have 10 volts at our battery, and we have 10 volts at the other load as well. For the current's going to add up. So if we have 3 amps on one of our loads and 4 amps on the other load, then our total amps is going to be 7. All right, that's it then for this video. Let's move on to our next task.